Hello and welcome to Weekly Dev Tips. I'm your host, Steve Smith, aka Ardalis. This is episode 19, where I'm going to provide a few reasons why you should learn the strategy design pattern. Don't forget, you can follow Weekly Dev Tips on Twitter, as well as in your favorite podcast app. And if you're finding these tips to be helpful, please take a moment to leave a review on iTunes or Stitcher. I really appreciate it. This episode is sponsored by devIQ. devIQ offers online training for software developers and designers covering topics like UX, .NET development, and ASP.NET Core. You can check them out at deviq.com. So why should you learn the strategy design pattern? The strategy design pattern is one of the most fundamental and commonly used patterns in modern object-oriented design. You should take some time to make sure you're proficient with it. I'm continuing here a small series of tips on design patterns that I started in episode 17. I encourage you to listen to these tips in order, since in many cases they'll build on one another. This week I want to briefly describe the strategy pattern, and more importantly, why I think it's a pattern every object-oriented software developer should know. The strategy design pattern is often referred to as a refactoring technique to improve the design of some existing code. The original code likely has some tightly coupled and/or complex logic in it that would be better off separated from the current implementation. I think one reason why I'm so fond of the strategy pattern is that it literally helps with every one of the solid principles of object-oriented design. In my solid course on Pluralsight, I also discussed the don't repeat yourself or DRY principle, which strategy can help with as well. Let's look at how. First, imagine you have a class that's doing too much. Therefore, it's probably breaking SRP, the single responsibility principle. You can use common refactorings like extract method and move method to pull logic out of that one big method in that class. However, if you then call this method directly from the big method, either statically or by directly instantiating a class to which you've moved the logic, you're not helping the coupling aspect of the problem. We'll get to that when we get to the D in solid. Now, applying the strategy design pattern in this case is really just a slight twist on the usual extract and move method refactorings. You're still doing that, but you also typically create a new interface and pass in the interface to the original code. After moving the original implementation code to a new class that implements this new interface, you should have a new class that follows SRP, and your original class should at least have fewer responsibilities. Considering the refactoring I just described, it's easy to see how it can help with the open-closed principle, or OCP, as well. Whereas the original code's complex logic would have needed modified and recompiled any time a change was requested, the new design can accommodate changes in the implementation of extracted method by writing new code that implements the same interface. Then, an instance of that new class that was just created, which has this new implementation, can be passed into the existing code without touching that existing code. This is what the open-close principle is all about. I talked about how important this is with legacy code in episode 15. Getting to the L in solid, if you have multiple implementations of your abstract types, it's important that they all behave as advertised, otherwise you may encounter runtime exceptions. Ensuring that any implementation you write that inherits from another type, whether an interface or a class, means that you're following the Liskov substitution principle, or LSP. Following LSP is much easier when the base type's behavior is fairly small. Large interfaces require much more effort to fully implement than smaller ones. The interface segregation principle, or ISP, suggests keeping interfaces small and cohesive so that client code doesn't need to depend on behavior it doesn't use. Done properly, the interfaces that you create while implementing the strategy design pattern should be tightly focused and very small. That brings us to the last of the solid principles, the dependency inversion principle, or DIP. This is really what the strategy design pattern is all about. Whereas the initial code was tightly coupled to a specific implementation, the refactored version of the original method now depends on an abstraction, an interface. Instead of the original method deciding how to do the work, the code that calls the method makes that decision by deciding which implementation of the interface to provide. If you're familiar with dependency injection, then the strategy pattern should already be familiar to you. Make sure you're comfortable with pulling out dependencies when you discover them, though. The method extract and interface creation aspects of the strategy pattern are not always emphasized when dependency injection is taught or discussed. We're out of time for this week, but I'll mention that the strategy pattern also helps with the dry principle by creating a single place for particular implementations to live, as well as the explicit dependencies principle by ensuring that classes request their dependencies rather than hiding them in their methods. You can learn more about these principles from the show notes at weeklydevtips.com/019. Would your team or application benefit from an application assessment, highlighting potential problem areas and identifying a path toward better maintainability? If so, contact me at ardallas.com and let's see how I can help. That's it for this week. Thanks for listening. See you next time on weeklydevtips.com.